Hello guys, now let us discuss question 23. The question is, in the Young's double slit experiment, the slits are separated by 0.5 mm and the screen is placed 150 cm away. A beam of light consists of two wavelengths 650 nm and 520 nm is used to obtain interference fringes on the screen. The least distance from the common center maximum to the point where the bright fringes to the both wavelengths coincide is, the option are: first 1.56 mm, second 7.8 mm, third 9.75 mm, fourth 15.6 mm. So the correct option is 7.8 mm. Here it is how. So the for the fringes of the wavelength 1, the formula is y is equal to m lambda 1 d by d. And for the fringes, similarly for the fringes of lambda, it's y is equal to n lambda 2 d by d, because we don't know the number of fringes. That is different for both. Now, for the hence the distance from the center maximum to the point where they first must be the least integral multiple common to both. So for that we do m divided by n, which is equal to lambda divided by lambda 2 from these two equations, from this to this, and then we divide, we get 4 and 5. M is equal to 4 and n is equal to 5. So now for particular for the distance of lambda 1 wavelength. So we just have to we know that y is equal to m lambda 1 d by d. So just we have to put the value of m, as we know m is equal to 4, and we know the other value that are given in the question, that is 650 nm, and it is 150 centimeter away. So just putting the value, and it is separated by 0.5 mm. So we get 7.8 nm, which is the second option. So the second option is correct. Here the solution is that lambda 1, so lambda 1 is equal to 650 nm, that is given. Now for the y is equal to 4 into 150 into 10 to the power 2 into 650 into 10 to the power minus 9, divide by 0.5, it's separated by 0.5 into 10 to the power minus 3. So the correct, from this we get 7.8, so the correct option is 2.